Here we'll solve a polynomial inequality. Notice that this polynomial is already split up into factors, where we have an x times x minus 4 times x plus 2 times x plus 5. For scenarios like this, what we'll do is split that polynomial into multiple pieces and solve each piece. We will set all of the pieces equal to 0. So we will have x equals 0, x minus 4 equals 0, x plus 2 equals 0, and x plus 5 equals 0. Now, if you ever have x equals 0, don't do anything to it. It's already okay as is. This means that 0 will be one of our solutions. For x minus 4, we'll take the minus 4 and move it to the right and end up with x equals 4. Do the same thing to the positive 2. When we move it to the right, it will become x equals negative 2. Do the same thing to the positive 5 and move it to the right, and we will get x equals negative 5. Therefore, we will find 4 values of x in this inequality that make the expression on the left become 0. Those are 0, 4, negative 2, negative 5. Let's begin by drawing a number line. We place our infinities on the left and the right, and now we look to the symbol to tell us what to do. The condition we have here is greater than 0, and greater than 0 means positive. So we'll make a note of that below the number line that our condition is that we want positive answers and we want open circles. We'll place an open circle at 0, place another one at 4, and some more circles at negative 2 and negative 5. Those open circles will split our number line up into multiple regions. We'll have a region A, B, C, D, and E. So we have 5 numbers to place in and check to see which regions will give us a positive answer. Let's do that on the next page. We'll begin with region A, and we'll pick an x that's to the left of negative 5. Let's try x equals negative 7. If we plug in negative 7, we'll have an x on the outside first. Then we'll have x minus 4, so that is negative 7 minus 4. Then we'll have negative 7 plus 2. And then negative 7 plus 5. Let's have a look at our signs. Our first term is, of course, the negative 7 by itself on the outside. Multiply that times negative 7 minus 4, that's negative 11. Negative 7 plus 2 is negative 5, and negative 7 plus 5 is negative 2. So you can see that all of our terms are negative, and we have 1, 2, 3, 4 negatives. We have an even number of negatives. Anytime you have an even number of negatives, the answer will return positive. Anytime you have an odd number of negatives, the answer will return negative. Therefore, the answer has returned positive for region A, and that is a match for our condition because we want a positive answer. This means region A will be part of our solution. Now we'll continue the process for region B and pick a number in between negative 5 and negative 2. Let's try x equals negative 3. Therefore, we'll have negative 3 on the outside, then negative 3 minus 4, then negative 3 plus 2, and negative 3 plus 5. If we do the math, we'll have first a negative 3 times negative 3 minus 4, which is negative 7, negative 3 plus 2, which is negative 1, and negative 3 plus 5, which is positive 2. This gives us 1, 2, 3 negatives, which means our answer will return negative because that is odd. However, the condition was that our answer must be positive. Because our answer for region B is negative, that is not a match, and region B will not be part of our solution. Continue to region C now, and pick a number in between negative 2 and 0. My temptation is to try to pick 0, but since that is one of the open circles, we cannot use it. Instead, let's use x equals -1. So we'll have -1 on the outside and -1 for each of our x's. I'll place that now. Therefore, we'll have -1 first, and -1 minus 4 gives us -5. -1 plus 2 gives us +1. -1 plus 5 gives us 4. Therefore, we have two negatives, -1 and -5, that is even, and so our answer will be positive for that region. Positive is the condition for this inequality, therefore region C will be part of the answer. Let's do the same thing for region D. Pick an x that's between 0 and 4, and we'll just use +1 here, and we'll place +1 in for every x. We'll have 1 as our first term, 1 minus 4 gives us -3, 1 plus 2 gives us +3, and 1 plus 5 gives us 6. We have a single negative, which is odd, which gives us a negative answer. However, that does not match our condition, so D will not be part of our solution. Finally, we'll do the same thing for E, and we'll pick an x that is greater than 4. Let's just use 10. We will place 10 for all of our x's. We'll have the 10 from the outside, and then 10 minus 4 will give us 6, 10 plus 2 will give us 12, 10 plus 5 will give us 15. All of our terms are positive, therefore we can expect our answer to return positive. This does match the condition, and therefore region E will be part of our answer. Now that we have the picture, let's find what the intervals are. We will have 3 intervals in our solution set. Those intervals are A, C, and E. To show that we have 3 intervals, we'll write A, C, and E with a small u in between them. The small u stands for union. This is just to show that there are multiple intervals in our solution. Piece A starts at -infinity and ends at -5. So we'll write -infinity, comma, -5. Infinity will always have a parentheses, and because the -5 is open, it also has a parentheses. We'll say union and now move on to region C. Region C starts at -2 and ends at 0. So we'll say -2, comma 0, and again put parentheses around them because both of them are open. Then we'll say union region E, which goes from 4 to infinity. Again, the 4 is open, so we'll have a parentheses. And infinity always has a parentheses. Therefore, our solution set is -infinity to -5, union, -2 to 0, union, 4 to infinity. This will be the solution set for this inequality.